present today. I'm Salome Thakur, Assistant Project Manager at Cloud Counselage Pvt, and I welcome you all to this webinar, Harnessing Artificial Intelligence. The agenda for this webinar is as follows. First, we'll know about Cloud Counselage Pvt, that is CCPL, and Cloud Counselage Gift Career Foundation, CCGSE. After that, we'll try to know about the guest speaker a bit more for today's event. Once we know about him, we'll try to understand what is artificial intelligence in detail. Lastly, we'll have the Q&A session. So for all the guests present today, I'm sure we must have interacted before through various other events held by Cloud Counselage Pvt. But for those who are new and are engaging with us for the first time, we would like to walk you through who we are and what we are trying to do. So Cloud Counselage Pvt is an IT and management consulting and advisory company with a social cause at heart of helping the students community. We are based in Mumbai and we are on a mission to build IT and management capacities pan-India. With respect to our services, our major services are consulting and advisory in the domains of IT and management, wherein we leverage the latest technologies to help the businesses. We also have our own products, and we are very proud to say that our interns also contribute towards building these products. We have various programs to support the academia as well, namely the IAC, that is Industry Academia Connect, and the IAC CCPC, that is Industry Academia Connect Cloud Counselage Professional Community, which gives insights on the latest technologies, best industry practices, etc. We let you know more about this in some time. We also have our cloud store to add value to our cloud businesses and our partner businesses. Cloud Store provides varieties of solutions that include servers, learning management, hosting, workspaces, etc. We have catered to multiple industries like fintech, technology, FMCG, IT, banking, and infrastructure. In terms of our workforce, we have our workforce spread across 6 countries, which includes our affiliates, our partners, our associates, and our interns as well. In terms of our journey, we started in 2015, where we registered as a private limited company with the Ministry of Corporate Affairs. Then in 2016, we were working and branding our services through various events. In 2017, we started taking consulting projects in London, and 2018, we worked on the flagship project, which had its operations spread across 120 countries. In 2019, we started to streamline our operations in India. This was also the time when our founder, Mr. Tushar Tupale, received the Star Alumni Award from his alma mater. That is when he realized that things have not changed much after almost a decade, and he remembered his struggle, which he went through to get his first good job. There were no campus placements or mentorship provided, and it all reminded him when he visited his campus. So he decided to do something for the student community as an organization, and that's where we initiated the Industry Academia Connect. To deliver the Industry Academia Connect and to achieve this vision of helping the students community, we have established a foundation, which is a not-for-profit organization called as CCGSE Foundation, that is Cloud Counselage Gift Career Foundation. And through this foundation, we'll be helping the students to achieve their dreams vis-a-vis their professional life. And this we are going to do through our Industry Academia Connect initiative. Industry Academia Connect, or IC, was also initiated in 2019, and we have participated in many events with the government bodies, with the universities, and we've conducted various webinars and other events for the students. And along with that, we have onboarded 1,000 plus interns from across 150 colleges in Maharashtra. We want to help even more students pan-India, and this is a second year, and we want to give more to the students community. So what are the activities that one can get to encounter through ISC, and how ISC through the Cloud Counselage Professional Community is going to help the students? The intent of ISC CCPC, which is Industry Academia Connect Cloud Counselage Professional Community, is to provide a platform to the young generation, the Gen Z of India, to participate with the industry. The essence of Industry Academia Connect is that it enables the complete Industry Academia Connect on one single platform. And one such activity under IIC CCPC initiative is the monthly webinar or talks with the community. One such professional we have today is Mr. Arya Bodhankar, who is a research degree student working in quantum computing. He is proficient in artificial intelligence and has conducted various workshops in ML and AI. He has also led teams on academic and internship levels. for AI projects. And last but not the least, he has also been an intern at Cloud Counselage, where he has worked on projects in AI and ML. Today, we have the honor and the chance to listen to him to understand more on the topic, harnessing artificial intelligence. Without any further ado, I would request Mr. Bodhankar to take over and explain us what is artificial intelligence. Over to you, Arya.
Thank you, Saloni. Hi, everyone. My name is Arya Bodhankar. A very good afternoon to you all. And I shall be your guide through this webinar on harnessing artificial intelligence. So before we begin, there is a small setup that I would like you to do, which involves having a smartphone at hand because the webinar has a lot of QR codes. And I would like you to scan the QR codes or at least click photos of the slides when I ask you to, so that you can visit those links later on. Also, make sure that you have the video resolution on a good quality so that the QR codes are clear enough. Lastly, the verbal content of this webinar will be more than the written content. So I would like you to listen to that groovy playlist later and enjoy. Hope you get some information about the webinar. Basically, this webinar does not go into a few things and it goes into some specific things that I would clarify right now. It doesn't go into machine learning theory because machine learning theory is a very vast subject and it's not a really good topic for a webinar. I will provide you with a lot of links that should keep your theoretical and practical mind busy for the next month or so, hopefully. So there's no worries on that side. It's the same for specific algorithms or quick mastery shortcuts, which is actually a myth. You cannot quickly master machine learning or AI as such. Teaching AI in depth is absolutely out of the question, and giving a crash course is not the intent. The intent is to help you realize what is practical AI. That does not mean AI in practical use. It rather means, as in, I will not guide you through some practical projects as such. I'll tell you how AI is related to industries and implementations. How is it related to machine learning? Because we find in today's age that people think AI and machine learning are synonymous with each other. Then I'll tell you with whether AI or ML is good for you. You'll basically find it out by yourselves as you by the end of this webinar. I mean, I'll tell you with how and where to start in this vast domain, what kind of strategies would be helpful for you, and lastly, what kind of career is looking forward. Let us start. Artificial intelligence is practically a superset of machine learning, which in turn is a superset of deep learning. So you can be an ML engineer and you would still be working under artificial intelligence. But if you are working in AI, that does not mean that you will also be working by default under machine learning. The formal definition can be said to be an ability of an artificial system to perform tasks generally associated with intelligent beings. So intelligent beings being obviously humans. But the last point is quite important, wherein the intelligence is not about the machine, but the task. Your or mine computer is not an AI, or it is not related to the AI that we are talking about. The algorithms which perform the tasks are what counts as AI, because the tasks are what are intelligent, if I'm making sense to you. I'll expound more on that later. So artificial intelligence has types, as ML as algorithms. This is kind of different. This is task oriented. The first is narrow AI or ANI, artificial narrow intelligence, which is skilled at very specific tasks and it is designed and trained for those singular purposes. Today, ANI is everywhere. Facial detection, night mode in our cameras, text prediction, you name it. Everything has ANIs, and that is a very mature field. Skipping ahead a bit, if you go into artificial intelligence right now, you will be more or less working on ANIs. The next is general AI or AGIs. These are called all-rounders, which means they can perform a lot of tasks like how we do. A very basic AGI would be having the cognitive capabilities of a 5 to 10-year-old kid, which is still a big deal for us. And AGI is at least a few decades away from practical use. An example that I would give, which is moving on towards AGI, is OpenAI's GPT, which is the all-rounder of text-based operations. So imagine that you have something which can do practically any task in text. Now combine an AI which can do any task in machine learning, computer vision, you can say, or audio processing. So when all of these come together under one system, that's called an AGI. The last one is a super AI or an artificial super intelligence, which will be better than humans in anything that you can think of. They will practically be a consciousness which is superior to us. And some examples include Hector, Wiki, three supreme intelligence or the matrix. Like there are some those among you who know all of this. I know you're already interested into AI, so you don't need to be told what these are. But essentially, uh, all of these criteria can be categorized based on human involvement. In ANI, it is basically handheld. The humans have to handhold those models, provide them data, provide them parameters and constraints, and then they will be trained towards AI tasks. AGIs require data, but they do not require specific human intervention. They can process the data on their own, and then they can achieve the tasks that are desired of them. ASIs are basically, you can think of them as separate entities. They are like you and me, and far much more than you and me, and they don't need to have any human involvement in what they do. But rest assured that those are many decades away, and we don't need to worry about those right now. So artificial intelligence applications, most of you would already know about applications, but you can say that these applications include image analysis and enhancement. An example I'll give is super resolution. You can give an image that is 100 pixels into 100 pixels, and the AI will upscale it to 400 into 400 pixels without much loss of information. That is an example of image analysis. Another is object detection. You can detect objects inside images and all of that. Natural language processing, which is also a domain in machine learning. So this is basically dealing with text, text prediction, text analysis, semantic analysis. Everything comes under natural language processing. Audio analysis and enhancements. So there are artificial intelligence systems which can compose music nowadays. It's that level of complexity that we have reached. But otherwise, analysis would more or less mean increasing the quality or isolating stems. Isolating stems, which means that if I have a song that I give to you, you will feed that to the AI, and the AI will isolate the vocals from the background music. This is called isolating stems. Adaptive cybersecurity basically means that you are preempting the attacks by predicting any anomalies that occur in the system. Digital assistants, Alexa, Siri, Cortana, and any that I missed. Video processing is more or less a combination of image analysis and audio analysis. Predictive services are linked to what I referred to in cybersecurity, but here the predictions can be in practically any field. So you can predict the behavior of stock markets. Maybe you can even predict the behavior of voter elections. The ethics aside, this is a very big market. And I can go on more into the applications, but it's too much. So we'll move on. Structure of AI applications. So basically, AI, as differing from ML, is that AI is oriented around applications. Applications, as in the application that we see, Android apps, web apps, any of that, direct applications. So the system involves a black box. You can consider that whatever happens inside the AI is a black box, which means that you as a user is concerned only with providing an input and getting an output. And the data that is required for the AI system to act is the concern of the developers. But that's it. So you can see the system here. It involves an input, an AI system, model data, and output. The AI system itself need not necessarily have machine learning or deep learning. It can also be rule based, as was the case in chatbots of 1990s, 1980s, where you can say that they were built using a very complex if-else logic. If the user says this is the output that I'll give. So that is still under AI because to the end user who is chatting with the chatbot, it is still an intelligent conversation to some extent. Regardless, the backend of the AI can implement anything. And nowadays, you will mostly find deep learning implementations on respectable sized AI projects. Let's look at an example. I hope you recognize this app. It's called Wombo.ai. And we have a very famous person here singing a song which he actually never sung. So this app basically takes a static image and it will output a lip sync video like the one that you see. It's cute. But you will never find something like this in real life, which is the advantage of Wombo and things like that. So how does this system actually work? This is more complex than it looks. because it is a static image. You can imagine that. The backend is a very complex deep learning system which involves generative and convolutional models together, which map facial key points and then use a novel approach called first order motion, which they invented to carry out the motion. But when you are an AI developer, you will be more focused on the app, the IO of the app, which means that you will focus on getting a model and then implementing that model in real life or in the applications. So DL is a very core way of pulling this off, but still, DL is not needed for you to learn if you want to implement Wombo because the model already exists and you can use that into your own application. Another example, which is far more interesting, is NVIDIA's Gauguin. Now, if you look at this image, the first impression is that I am a really bad artist who has made a really bad reproduction of the scenery on the right. But the real situation is that this image on the left is my original artwork, if you can call it artwork. And I've given this image to NVIDIA's Gauguin, and it has reproduced my image and bettered its quality by 10,000% and given out a realistic output on the right. So you're right. The image on the left is actually the input. It's a segmentation image that is an input, and the image on the right is the output of the AI. I can actually draw whatever I want on the left based on the categories that you see here, and the AI will give an output as you can see on the right. It is quite novel and really scary to think that AI has reached this point in life, or in reality, where it can achieve such results. Now, AI or ML options. AI or ML options, I will speak to you in relation to Wombo and Gauguin. So the two options that you have right now is an ML path and a non-ML path. So you remember me saying that AI requires ML or DL or a rule-based logic. So does that mean that the non-ML path will take you through a rule-based logic alone? Absolutely not. Because in today's age, rule-based logic is obsolete, nearing on obsolete. It still has a few fringe use cases, but usually you will find deep learning implementations everywhere. So what does the non-ML path actually mean? See, for that you need to understand that AI is a concept. Machine learning is a technology which is a means to an end, the end being artificial intelligence. You use machine learning to achieve AI. But does that mean that you need to know machine learning to its core? Absolutely not. I will give you an example of Wombo. Wombo it uses a pre-configured machine learning, deep learning model for first order logic, and it tweaks it up for its own specific use cases and then uses it to create an app that can perform those magical sounding lip sync videos. Which means that if you are an AI developer who has knowledge of what each kind of machine learning or deep learning model can do, without going into the details of how the model works or how is it constructed, you can still be an AI developer who is developing applications for practical use. The most, as you can see in the last point, most standard applications can be built using both applications, which means you can start from scratch or you can use a hybrid model. Womble uses pre-trained models and optimizes it as per their preference. Womble, which means that it employs both AI developers and machine learning developers. Now we'll go into the outline of each path. First, the ML path and then the non-ML path. The ML path basically enables you to do the following things: model optimizations for accuracy and custom data, which means that you can decide how accurate you want your model, what kind of data do you want it to work upon, how fast it is, how small it is, how much time does it take to train, even not even talking about the execution speed, but even the training speed is very important in today's age where you see models being trained in real life. In-house. In-house model means that you don't need to depend on a third person. Let's say that you are a company of your own. You can develop your own models and keep that to yourself for your specific use case. Custom solutions as per requirements, obviously, because making tweaks is very easy when the model is your own of your own engineers. Or even if speaking outside a business perspective, you as a developer have absolute control over the model that you have built. Fine grained control, as you can see. It is also modifiable as per future needs, which means that let's say you have an app today which increases the resolution of an image. So you have built a model and all good. But next day, as in or the next year, you will find that your users are demanding a way to convert black and white images to colored images, a grayscale to colored type of system. So you, as the progenitor of the model, can fine tune that model, retrain it, give it new data so that it can do that as well. Deep learning models today can do multiple functions, so that is viable. Or you can just train a separate model that can be added on top of the first one. But basically, you have that freedom because everything is your own. Developers have a strong understanding of working, obviously, because of the above, and the advantages of that are already explained above. Job flexibility in AI and above roles. Now, this is slightly doubtful because it depends on the user, the coder, the developer. It depends on you. You can be an ML developer because you have chosen the ML path, and you can shift to AI. So, what will you require to shift to an AI development or the AI industry? Again, going back to, let's say, NVIDIA Gauguin, the drawing example. Let's say that you have implemented Gauguin model, but now you have to implement that into an application that the users can use. That is basically the point of AI developers. You need to use the means to reach the end of intelligent tasks. So you might need to learn browsers, how to use a browser-based servers, Flask servers maybe, and then you will have to use how to learn. You will have to learn how to use Firebase or Amazon Cloud, where you will execute your model. So those are technologies which are traditional. You can learn them faster than the reverse, which means that if you are an AI developer who is prone to using existing models, and then you have to go into ML, then the amount of efforts that you will require to learn ML from scratch and then go venture into that field are far more than what you require to shift from ML to AI. But the non-ML path also has its advantages. Firstly, is the honorary mention, you can say rule-based logic, which means that there is no ML or DL used here. That can be used, but I do not recommend that. Next is pre-trained models, which encapsulate the ML know-how. That basically means that you can use models that have been trained by someone else on their own data, and you can use it for your own applications. So this means that machine learning models can be exported. Machine learning models are basically parameters and weights that can be used in multiple applications, not necessarily the one which it has been developed for. So pre-trained models can be used by AI developers in their own application, you can say. For example, if I have a model that is trained on increasing the resolution of an image, on of images which are of a scenery or a landscape type model, I can retrain that slightly so that it will be also applicable for images of cities or maybe something related to a landscape, close by at least. So what next? So what's the advantage of using a pre-trained model? It's rapid implementation because you don't have to develop the model. You just have to implement it. Transfer learning is the magic word here because let's say that we'll continue my example where I said that you have a landscape image model and you want to train it on cities. So obviously it is trained on landscapes, so you cannot just implement it on your own system, which means that you need to give your own data to it and train it furthermore, saying ki, okay, you have been learn to how to process landscapes. Now you have to learn how to do it for cities. So it is like training a human. If let's say that you train a human to shoot a pistol, and then you give him a rifle, saying ki, this is a slightly advanced or a different version. The human who has learned to shoot a pistol will learn the rifle faster than the human who has absolutely not learned anything at all. You can think of transfer learning in a primitive way in this logic. So transfer learning is something that AI developers do a lot. They will train existing models on their own data and then tweak them as per their needs and then deploy them. Okay, what next? This is one of the most largest advantages, which is that it has a focus on solutions development instead of machine learning, which means that let's say that you are a visionary who has got an idea of a very good artificial intelligence implementation. For example, I said that you can split a song into the vocals and the background separately. So you will be like, okay, this is very, very great, and I need to implement this somehow. So if you focus on building a model for this, you might not be able to get it out into the industry, even if you are successful with the model. So there are people who are more focusing on the creative side, which means that they'll use existing solutions, combine them, use transfer learning, retrain models, and create a system that can perform exactly what they need. This is an advantage. So you can be more diversified. You can be an Android developer who wants to include AI into his app. That is totally fine without having to learn how the specific model works. Then another part is reliable model implementations. So most of in the industry, most of the models used in the AI field are reliable. They have been tested by a lot of people. They have been researched for their weaknesses and their strengths and cross-verified over multiple use cases so that you have confidence that the model you are implementing in your own project, in your own product is reliable and your app will be stable. When you build a new app for your own system, a new model, sorry, those models are not tested. It may take at least a year or maybe a few months to get the model tested, and it's the users who will have to do those tests, which can be damaging for your service or product. And so industries may often prefer existing models when it is known that the existing models are quite good. So you don't need to develop your own. So this is an advantage because it puts AI developers into demand. You don't need everywhere. You don't need ML developers everywhere because it's like reinventing the wheel at a lot of cases. An example I'll give you here is that there are a lot of smartphone manufacturing companies, and practically every one of them advertises an AI camera or something like that. So why would they implement each and every model required for their AI camera from scratch? It doesn't make sense. If there is a very robust object detection system model available open source or even in provided by any service, they can totally go with that because it is reliable and it is efficient. So they will need AI developers who can understand how the models work, tweak it to their own requirements, and then deploy it in a reliable and stable application. Lastly, there is a flexibility to pursue other fields. As I said, that let's say you're an Android developer, you don't need to forsake Android to go deep into ML. You can do it simultaneously. Now it's granted that a few ML developers will come to me and say that I am doing ML alongside other fields. Yeah, that is great. But if you want to have a mastery inside ML, it will take away your time from other fields. So that is not the case with AI, relatively speaking. And okay, how to start? This slide is more for people who already know what path they have uh, taken up. So let's say that you have taken an ML path. You will use a bottom-up approach, which means that you will start from the basics. You will start from classification and regression and all that, and you keep on increasing complexity until you reach convolutional neural networks, then deep learning, generative networks, and so on. You start with models first and applications later, which means that do not focus on what kind of fancy stuff you can get out of your models. Focus more on how efficient, robust, fast, usable models you're making. And yeah, obviously, once you are somewhere into this process, you will like to start making your own custom models because that is the singular advantage of ML over the non-ML path. Ekdam last, at the very end, you will implement your models into apps. Now, this is a stage where you will most often work with AI developers at your side. So this would be around somewhere in the job stage or in your project or internship stages, where you will work with AI people and implement your models into an app. This is the entire bottoms-up approach. And now for the non-ML part, there is a top-down approach, which means you start from existing models and solutions, that is pre-trained models, whether or even services which do not uh, need you to use a model at all. For example, if you use Google's Auto ML, it just asks you to give an input and it will output you the whatever is needed. For example, the Google's Auto ML Vision API will just ask you to give an image and it will say that the image contains these and these colors, these and these objects. That's it. So you can start developing applications from that without going into the models, and then slowly go towards using pre-trained models, understanding the pre-trained models, go deeper into how are those models trained, what kind of data sets are used, how to make your own data set. Because when you are into a non-ML path, you'll need at least your own data set to retrain those models which are trained on existing data sets. Build applications, build as many applications as you can, and then go on into tweaking and building your models. Lastly, both of the approaches, bottom up and top down, meet together for development. ML path starters, I would say, theory is really good for ML. So this is one of the slides where you can take a screenshot or scan it. The two QR codes given here are basically resources which can be used for the ML path. The first is a TensorFlow page which has a very comprehensive guide on all of the resources that you can need for TensorFlow. It is primarily oriented around TensorFlow, but it will be useful to you otherwise also. The next is the Stanford ML Coursera course by the legendary Andrew Ng. It's practically a staple now, and every time you ask any senior or an expert, they'll recommend you to this course, and I'm doing my part. So these are called MOOCs, basically massive online open courses, the ones like on Coursera. So it is recommended that you do an MOOC for machine learning and right away start with practical learning and then move on to smaller projects and all and take the larger projects. An example is if you want to go into computer vision, start with the MNIST dataset and make your way towards ImageNet. Or in natural language, you can start with Amazon reviews and make towards GPT-2, which are quite big. For non-ML path, which is the AI path, you need not go for an MOOC, online course. For example, the links here are Google AI's page, Google AI Education, and there is a site called PAIR, People for AI, which is a very good site for visualizing machine learning models. So because visualizations are important for AI developers, that helps you to skip all the mathematics and understand how the models work by tweaking the parameters. Here also emphasis is understanding what the model does as compared to how it does it, what over how, and dive deep into ML and all afterwards is the same thing. An example I'd give is if you're making a chatbot, you can start with Google's Dialogflow, which does not need you to use models as such, and you can move on to Rasa, which uses advanced level models and still keeps things partially encapsulated, abstract. Now, which approach to choose? This slide is pretty self-explanatory. If you're going for full-on ML AI, choose the ML path. If you're interested into models, granular control, if every single parameter you want control over to change, to optimize, to increase the speed, whatever, then ML is the way to go. If you want a career into ML and AI, this is a better path. Also, you need to have a knack for research and exploration because not even every year, but every 1 or 2 months, you will have a landmark release of a machine learning model or a deep learning model that has revolutionized your field. So you need to have that research knack so that you can adapt your projects to the better technologies. Non-ML path, if you have less time to give, that means you're interested in a lot of other things, such as how I said, Android development. So you can do this concurrently. You're interested in making applications, which means you have a creative inclination to help people with AI instead of going deeper into how it works. Okay, and if you are just preferring tried and trusted approaches and downright hate debugging and all, AI is better. Although that won't let you escape from the other domains debugging. You can consider this a test. This is a blog on NVIDIA's Gauguin, the thing where you can draw ugly images and it will turn them into nice scenery. So scan this image, go to the site and read the blog. Read the blog and evaluate for yourself how is your understanding about it. So that blog is a simplified version of what they have implemented. So there are three options. If you felt that you would understand it with further digging, which means that there are a few words that you don't understand, maybe that's fine. But if you go deeper, you will understand this and you're confident that you can reproduce it. The ML path is best for you. If you found it was too technical or you did not understand much of it or you knew how to do it, but you're not inclined towards that, the ML path is good for you. If it absolutely made no sense to you, you are too new to this field and you should just explore more without jumping to a conclusion that the AI path is better for you. Because let's face it, deep learning is a scary approach, is a scary field when you look at it immediately from the outside. You should start with machine learning first. This is a deep learning implementation. Now, let's say that you already have experiences. A lot of you might have already ventured into MOOCs or blogs, medium blogs towards data science, or whatever. So you know that what is my field and what should I do next. What I would suggest you is to take the Fast AI Deep Learning course. The QR is given here for version 3, which is the latest version. So it's a two-part course where in the first course, it will teach you about core concepts and the second part, it will be more into various deep learning concepts. So why am I recommend you this course is because it is good for people with a lot of experience, as also for those with less experience. This platform is so good that it will tell you how Jupyter, Colab, and Kaggle works, how to set these things up, how to use your GPU for parallel computing into training models and all. So you will not find a more comprehensive source than the Fast AI Deep Learning course. The only thing here is that it uses Fast AI's own library, but that should not be a problem so long as you get all the concepts of the course. It is ideal for everyone if you know what kind of models are existing in deep learning, but without knowing how to implement them, you should go for this. If you have already implemented deep learning, you should still go through this, just go through the contents of the course. I'm sure you will find something that will be helpful for you because it is quite vast. So, as in, it's so vast that if I open this site right now and run you through it, it will take another half an hour. That's about it. So with this fast AI course, I have a target for you. I want you to share your progress in 6 months. You can do it via Cloud Counselage, or you have my contact details here. Another QR code, yes, where you can contact me via email or LinkedIn. And I would love to see what you do in 6 months. The Fast AI course is something that you should not miss absolutely. And I'm sure that by the end of the course, without even reaching the end of the course, you will already have so many implementations at hand that you would be confident in calling yourself an AI or ML developer, whatever is suiting towards you. That's it from my side. I hope you found this insightful and it has at least helped you to solidify your approach towards ML or AI or both. Both is also cool. And that's it. Thank you. I'll now hand it over to Salome.
Thank you so much, Arya, for letting us and the community know more about artificial intelligence. I would now request Swarnadeepa, our HR executive, to take over the Q&A round. And before we go ahead, I would like to tell all our ICCPC members who are watching this event, you can log into the company platform and type in CC Assist in the search bar as shown in the screenshots. Next, you can type in your questions or queries that you have for the guest speaker. And you can also follow similar procedure on the mobile application to ask your question to the guest speaker. Over to you, Swarnadeepa.
Thank you, Salome. And thank you, Arya, as well, for such a detailed and insightful presentation. So, for everyone, this is the right time and right platform to uh, put your queries. So, as directed on the slide visible at your screen, you all can post your queries. Well, so we have the first question with us. Uh, that is for Aryan, and the question is quite interesting. So, the first question is why is game theory important to AI?
Okay, thank you for this question. This is actually a very interesting question. Game theory is important for AI because, as I said, that AI is a means to an end. The end is that you should have tasks, you should be able to achieve tasks which are intelligent. Game theory is basically important for rational decision making. It is important, it is a mathematical field predominantly, but the field helps you to take decisions which are more tending towards what humans would take. That is why game theory is important for AI. So the thing is, game theory started out when deep learning and machine learning models were not that evolved, which means that you needed to work using standard mathematical algorithms and try to tend towards having models which are important in taking decisions which correspond to what humans would take. That is where the foundation of game theory lies. It dates back many years before deep learning even came into existence. That is why it is a fundamental in AI, and it is often taught before any of the other models when you are learning AI theory.
Okay, thank you, Arya. So, we
Yeah.
have the next question coming in. Yeah. So, Arya, could you please tell us more about the projects that you have worked on AI?
Yeah, sure. So the projects that I've worked on, I've already spoken about a few of them. One was an image super resolution project that I worked on two levels. One was for a website and another was for an Android app. wherein my app basically what it does is it takes a lower scale image and it upscales it into a high resolution image using deep learning models, DCGNs, deep convolutional generative adversarial networks. So what it does is it will take 100 into 100 image, upscale it to 400 into 400, and it will generate the information that is needed to fill in the extra pixels. So this was an AI project because I used an existing DCGN model. I actually, and this is an AI application because I had to research upon a lot of models and pick one so that I could use an existing model and focus more on the Android side of the development, where if you need to work with ML models, you usually have to work on C instead of plain Java. So that is a project. Another project that I worked on is more into combo. So like I said, actually this is a nice thing to add on to that you can use AI into other domains. For example, I use AI into quantum computing to make a quantum machine learning model, which helps me to find out the correct parameters of the circuits. So this was an AI implementation which used machine learning in the domain of quantum computing. So it's a very good hybrid. So people who are diversified can go for such things. Yeah, that's I think enough for now. Oh, yeah, or okay, I'll just say a few more. I've also worked into natural language processing where I've built chatbots on multiple levels. So I've started with things like IBM Watson or Dialogflow, and I've moved on to RASA, where you use diet classifier models and BERT, and then towards models where everything is from the start. You have to do everything from the scratch using high-level models like Google's Albert. So basically, when you go into AI, you have the advantage of being a very diverse kind of person. Natural language processing, computer vision, audio, or even like other fields such as quantum computing, data science. If you are into ML or deep learning and you go deeper, the deeper you go, the more constrained you are. For example, if you explore generative adversarial networks, so most of your approaches, implementations, and projects would revolve around generative adversarial networks. So that's not a bad thing. It's actually very good because the implementations come that way. But if you are like me and you are more into implementing AI for a lot of use cases, you will find AI more appealing. Yeah, that's it.
Okay, that's great to hear, Arya, and it was quite elaborative yet specific. So moving on to the next question, Arya, I guess the next question is also for you.
Mhm.
In your opinion, how will AI impact application development?
Another very nice question. Application development, what I'd say is so right now, AI in application development is not a threat to humans or anything because AI is basically being developed by applications more. But the situation in the next 20 years, you can say, might be completely different. I'll give you an example. OpenAI recently released the GPT-3 model, which is a very massive machine learning model that can work with practically anything that you give it regarding text. This model is known to code on its own. You give it some kind of commands like I want to make an HTML page with a heading bar in the center and an orange colored background, and the model will code you an entire HTML page and output it for you. So this is the kind of implementations that we are going towards. And if that is the case today, then in 20 years, you might say that a lot of the lower level development can be affected by AI in an adverse way. But conversely, the more we move on ahead, development is getting easier and easier, which means that there are a lot of resources available for developers to use. And let's say that if you had to code a website from scratch 20 years ago, now you have a lot of libraries that will just streamline the process for you, which means that developers will still be a necessity, no matter what age we are in. But yeah, AI will develop it, affect it in such a way that the way we develop applications will change, definitely. Yeah.
Okay, that was insightful, Arya. Uh, Moving on to the next question. It's good to see actually we are having such engaging crowd coming up with so many interesting questions. So the next question which we have is also for you, Arya. When is it necessary to update an algorithm?
Okay. This question is kind of vague, but I'll take it. necessary to update an algorithm. What this would, I think, mean is that let's say that you have an implementation in a project. If you have, let's say, you can take the example of Wombo, the one with the dancing faces. So let's say that you want to update that. It is only necessary to be updated if you have a business need where you need more features, or if you are scaling it to such a large extent that your current hardware or your current infrastructure is not able to cope up with it. I'll give you an example. Let's say that you can take the example of my app where you increase the resolution of images. So my app would take approximately zero point 0.5 seconds to process it and give out the output. But let's say that I have 1 billion users who are concurrently using it. That can put a load on my processing power that is working on the cloud, which means that I'll need to build a model which optimizes it in such a way that it takes less time to give me the output, or it may take less hardware, it may take less hardware intensive measures to run the same thing, something like that. So that is when you should change your models. Algorithms as such are static. You don't need to modify your algorithms, because when you change an algorithm it becomes a different algorithm. So even that is a very good approach. If you think that your existing algorithm is not suitable for your application, you can switch on to a different algorithm. And that's actually where AI developers come into the picture. As in, it's not like you develop an application and the company will say, okay, now I no longer need you. Because of such things, change is very important. I think that would
Yeah,
be a fair answer.
yeah, that's right. Yeah, thank you. So moving on to the last question for today, I guess this question you have already shared in the slide. We had in this slide rather, but the question is from where can we learn the mathematics required for AI?
Okay, so the mathematics required for AI is basically the mathematics required for ML, actually, because AI is speaking about using existing implementations towards your own applications. If you are interested into the mathematics, I would recommend the question asker to go towards machine learning, because that is full of mathematics, especially machine learning, and less of deep learning. And the courses that are linked on slide what's it on slide 14 for ML path starters. The Andrew NG's course on Stanford Machine Learning Coursera platform will help you a lot with the mathematics of AI and ML.
Okay, Arya, that was quite insightful, and thank you for your answer.
Thank you.
So, yeah, so I guess for today, this was the last question. Henceforth, thank you, Arya, for such a wonderful presentation. And thank you, everyone, for attending the webinar. And thank you once again because we got to learn a lot about AI adroitly. Henceforth, thank you. Over to you, Salome.
Thank you, Swarnadeepa. And I would like to thank the guest speaker once again. Thank you, Arya. The presentation was very enlightening and comprehensive, and I'm sure the students also find it very insightful, and they'll go through all the resources that you have listed out, and it will definitely help them to start their career in this field. Also, I would like to tell the students that this was possible because of CCPL and CCGSE coming together under the IAC CCPC initiative. IAC CCPC offers 14 plus benefits, as you can see on the screen, which is corporate and industry exposure, online internships, access to our corporate systems, access to free technology and management training, off campus placement updates, monthly seminars or webinars, one which you're a part of currently, CV and profile building assistance, industrial visits, and job opportunity for high performers after graduation. Also, IIC CCPC activities are year-round and not seasonal. So this is one simple Gantt chart which we have, which will help you understand all the activities that take place over the months throughout the year. And the next batch will be onboarded in the next academic year. So make sure you express your interest in this membership on the ICCPC page. Apart from this, we have other benefits as well, as I mentioned earlier. You can see them on the screen. Please note that this membership or program is completely free of cost, and there are no financial liabilities or no costs involved for the students or the academia for this initiative. We do expect 1 hour per week to be provided by the students and 4 to 5 hours per month to gain the right industry academia connect. That is all that is expected from Cloud Counselage. Next, if you're a student and want to join the community, please express your interest by filling out the EOI form at cloudcounselage.com/ISC-CCPC. And if you're a faculty and want to associate your college with CCPL and CCGSC Foundation, please visit cloudcounselage.com/ISC. You can also reach out to us or follow us on the following social media platforms for all the latest updates and many other insightful events like these. And please take a screenshot of the same. Um, I would like to thank Arya once again, and I would like to call upon Arya for the parting words. Over to you, Arya.
Oh, parting words. I don't have any parting words as such, other than I hope you loved the webinar and it has helped you to get a clear insight into what you're planning after this. And if you have any queries, I'm always at reach by email.
Definitely,
Thank
Arya.
you.
So, thank you so much. On behalf of the entire CCPL team, I would also like to thank everyone on the team for making this webinar happen so smoothly. Thank you so much. See you soon at our other events.